Hello, welcome everybody to our AI Jam series, the show where we bring you real topics, use cases, and solutions on how to solve your challenges with AI. And today's discussion is sustainably scaling AI adoption. During our show today, if you have any questions, you can use the Q&A in the top to send some questions to our guest speakers. So today's AI workloads, they're really introducing new challenges for both hardware and software configurations. And they're stressing some of the limitations of physics and even location resources. So we're going to dive into those topics today. My name is Audrey Scribner. I'm here with my co-host, Anthony Delacali. Welcome, Anthony.
Hey Audrey, it's good to see you since Discover. That was
Yes.
fun. Now I'm excited about today, because at Discover, we saw so many of our enterprise customers and talk about the experimentation they've been doing over the past year or so, and really getting to more about operational states around their AI initiatives. Where I think today's topic, was clearly center stage in terms of looking at a maturity of it for adoption for AI. So I look forward to a robust discussion today.
Yeah, and yeah, we had a little bit of a break from Discover. We're all really hands on deck for that event. And I know that there has been a lot of presentations posted on YouTube as well. So if you didn't attend Discover and you want to hear even from some of our speakers today who were at that event sharing some of our latest breakthroughs, please go on YouTube and find some of those recordings. All right, so let's get into it. Introducing today's guests. Lynn Neese, an HPE Fellow, Chief Technologist for Sustainability Services, Advisory and Professional Services. Kareem Abu Sahab, Principal Technologist for Sustainable Transformation. And Jason Zeeler, Principal Product Manager for Power and Cooling. So Lynn, I'll hand it over to you first to introduce yourself.
Well, sure. Thanks, Audrey. And great to see you and Anthony again as well.
Mm-hmm.
So I'm more or less the CTO for our consulting business, and we've put a lot of our effort in the past couple years into understanding energy and emissions reporting and sustainability services associated with big projects for our infrastructure. So in a nutshell, this stuff is really central to where we're going as a service business.
Yeah, and I like your descriptive, practical yet optimistic visionary. I think I can always count on you to be very forward looking about what would be really cool and really possible, but also what you can actually get done today. So I always love hearing your perspective on that.
Awesome.
And
Optimism,
Kareem.
optimism keeps you going. So
Yes.
It
Yeah,
does. It certainly does.
totally agreed, Lynn. So yeah, thank you, Audrey. Thank you, Anthony. And my name is Karim Abu Dahab, and I work at HPE's Sustainable Transformation team, which is part of the wider Living Progress organization, which is the organization within HPE that is responsible for our climate goals, our IT sustainability strategy, as well as having conversations, with our partners, customers on how we can help them achieve their IT sustainability goals and do a bit of knowledge sharing, basically, amongst each other. So yeah, thank you for having me.
Mhm. Yeah, I
Thanks
love
for
I love your.
th-
Oh, go ahead, Anthony.
good. Well, I was just gonna thank him for joining. I know he's at the end of his day in Barcelona, so always a pleasure, Kareem.
True. It's a good
Yeah,
end of the day.
yeah, we have three countries represented on the call today,
Hmm.
so a good geographical presence and makes sense for this kind of conversation. And Kareem, so you said actionable IT efficiency and sustainability. Tell me more about your descriptive words there.
Yeah, so I chose that one because actually, back in my university days, I studied computer and telecom engineering. And throughout, I think it took me 4 years to finish that degree because it was an engineering degree. There was not a single time where sustainability or efficiency even was mentioned, right? They only teach us to use the best equipment there is, Budget is never a problem in university, right? The real life is really different than that, as well as carbon emissions, of course, are never a problem. So that's why throughout these conversations that we have with our customers, we try to focus on actions that they can actually undertake in their IT organization. And there's a bit of a disconnect, so to speak, between the sustainability organization within an enterprise and the IT organization within that same enterprise. Because the sustainability organization is talking only carbon, does not care about the performance, does not really care about what type of equipment they're using. So that's why I chose actionable, right? IT efficiency and sustainability, because any jump in efficiency means benefit in sustainability, basically.
Kareem, there was a headline in the New York Times yesterday that read, "Welcome to the tech grind era." And the days of the Google free lunches, they're gone, right? And it's with the impact we're making on energy in particular, the days of accountability and really driving to shared outcomes has to be the norm. And when I see a group like this come together, at a company like ours, I really get excited about the different types of skill sets it takes, right, to actually drive that level of accountability and actionable insight. So, look forward to your perspective, especially from Europe. How we're tackling this.
Mhm.
Thank you.
Thank you, Craig. And Jason, over to you.
Perfect. Yeah, thank you so much. So my name is Jason Zeiler. I am the product manager that leads our cooling and power portfolio in HPC. So really that includes all of our liquid cooling technologies, from direct liquid cooling inside of our Cray EX supercomputers, our Cray XD portfolio. So these are chassis level GPU systems and CPUs, as well as I work very closely with our compute organization. Part of the all for one HPE strategy is we're including very similar technologies and our products will work together. So we have to have a really cohesive marketing story, product story, even just how we service these products. And then I also play a role with what we're doing in power. So PDU strategy, we're moving into this world where what you think is a PDU, similar to the power bar, probably hooked up to your computer right now, they used to be pretty slim. Now we're moving to these monstrous PDUs that we're actually struggling to put enough of them into the rack because it requires so much power. And so we're in this new era of, we've already talked about this theme, sustainability, energy efficiency, but in HPC, performance is king. And so how do we align that performance expectations and also use as little electricity as possible so we have a good OpEx story, but even from a carbon footprint, we want to start paying more attention to that overall.
Yeah, I have to say, Jason, at Discover, your section on the floor was highly popular, and it was hard to even get a hello in with you because it was just, customer after customer coming up wanting to see the liquid cooling systems in action since we had them on the floor. So that was a really great experience for people who got to see that.
Audrey,
Yeah,
being a
well,
software guy in my life, I didn't get it either until I went to the basement of Houston's lab and I saw what liquid cooling actually meant and how we demonstrate it. And it blew me away that we were at a systems level engineered to get to that level. So I can see why his part of the floor was highly coveted. Yeah.
Yeah.
yeah, you want to see who's popping the breakers in Houston. It's the liquid
Ah,
lab because
it's the lab.
we're not running kilowatts, we're running megawatts of power
Yeah.
into a pretty small footprint in our massive, beautiful new campus. All that power is going to one part of the building because we're running Cray X supercomputers, we're running Cray XD AI systems. All of that infrastructure draws a lot of power, but it is very cool and it's very easy to sell. To your point, Audrey, whenever we bring stuff, it's an easy sell, right? Because it looks interesting. It's not super sci-fi. The world of Cray supercomputers. We're trying to make it look less exotic so that it is more easy to digest inside the data center. But when you open those doors, right away you look at it and say, wow, this is a lot of power. What are all these tubes? Wow, water is running through these racks. It causes a bit of a paradigm shift of What does it take to enable these big AI systems, HPC, and even just compute as we start scaling up?
Yeah, it gives us a good reminder about the physicality of it, right? We deal so much with the software layer, and at the end of the day, all of this runs on something somewhere. And so I think the tangible aspect of seeing that is just really impactful for people, and it really brings us to today's topic as well. So Jason, I wanna hand it over to you to kind of tee up a little bit for us about what's happening right now with AI and why are we talking about sustainable scalability, even as early as some might say, right? Like, oh, this will become a problem for later. I don't want to worry about it now. So why is this a problem or challenge now?
Yeah, so it is we're in such an interesting time right now where we're seeing all these big headlines about AI, this is the next industrial revolution, and there's a lot of really, amazing, innovations and planning happening for a lot of this infrastructure. But at the hardware layer, right? If we're trying to build the next dragster car, you need to use a bigger, more efficient engine, and it needs to go much, much faster to beat the generation prior. And that's exactly what's happening with all of our partners, that are manufacturing chips, NVIDIA, AMD, Intel. They are designing and launching some amazing new technology that at the end of the day is more powerful, and often more powerful equates to a higher TDP, or a thermal design power. So how much watts each of these things require. So last generation, say, of CPUs, what might have been a high-end CPU might have been around 200 watts. Well, today we're launching 400-watt CPUs, and those are going to continue to rise, and that's that orange line. And so that generation over generation is increasing. But the really wild part of the story, here's what's happening in GPUs. So not that long ago, 500-watt GPUs were something that we had to consider. How many of these can we put in a rack? They draw a lot of power. We already are deploying GPUs over 1,000 watts per GPU. And when we populate 72 or more of them in a rack, that's a lot of power. And so we're pushing very high into this chip density. And so that's an interesting thing that's happening in the market. But in this next slide, this is really the underlying story why I get a lot of speaker time. Is some of this stuff is really difficult to cool, right? So you can imagine as power goes up, there might be a linear relationship with how much cooling do you need for a 500-watt thing versus a 1,000-watt thing. But what's actually happening is, as NVIDIA or AMD, or whoever, they're designing these really exciting new chipsets, because they don't want to make the socket a foot wide, they're going to start stacking components on top of one another. So now there's GPUs, there's maybe an ASIC, there's memory, and now these components are packed full of technology. They are less tolerant of heat. And so that's where the T case is starting to go down, and going down quite drastically. In prior generations, we would see T cases, or the max thermal temperature, maybe somewhere upwards around 90, 95 Celsius, and these things could continue running, right? They wouldn't blow up, they wouldn't throttle too hard. We could really abuse them with an air-cooled system. Today's chips have much lower TK. Some I've seen are lower than 60 Celsius. So the drop is so large that we're now having to investigate new cooling technologies to more effectively kind of pull all that heat off of the chip before it throttles. And when you can imagine, let's talk about a 1,500-watt GPU. The ramp time on a GPU going from 200 watts to 1,500 watts can be seconds. And so how do you ramp up that cooling infrastructure, right? If it's had a fan in the server and it's just not moving fast enough, that GPU could quickly throttle and start shutting down. And so we want to have a much more effective cooling solution, which nicely also is more energy efficient with liquid cooling. So there's a lot of goodness. And that's why, we're starting to see more liquid cooled systems enter the industry, because really we can double dip in, again, performance and energy efficiency. And that's a really great story to tell. And that kind of brings us to this next slide, in that if we go all the way to the kind of holy grail of what is possible with liquid cooling, we want energy efficiency, we want high performance, we want density, but that energy efficiency part of the story can also actually be heat reuse. So imagine we have water coming into these racks. You know, we're gonna talk in Celsius today, so I apologize for those kind of, you know, native in Fahrenheit, but that's the language of the data center. We talk in Celsius. Often these data centers will bring in, let's say, you know, 27 Celsius water to the racks. Often what we can expect is a rise of somewhere around 10 Celsius. Now, 27 Celsius to 37 Celsius, you know, that's pretty good, but 37 Celsius isn't very warm. What we're starting to see are data centers that want to go much higher on the supply temperature, let's say 40 Celsius, because they want 50 Celsius water coming out the back of that rack, which they can use in some of these heat reuse applications. So this is heating the buildings. This is helping to grow vegetables. You know, we're seeing a lot of this definitely be driven out of Europe. And that's where I think we're going to talk a bit about, you know, leading markets versus laggards. Is there is this strong appetite for heat reuse anywhere electricity is expensive or land is expensive. And that's part of the narrative. So we're going to see more and more of that as we go here.
You know, Jason, we made this announcement last year at Discover with Danfoss, right, around a heat reuse solution application. And you know, just for the audience out here, Danfoss is an HP customer, but you know, also a partner developer, and they came to us. I mean, Danfoss clearly, you know, a very large player in um, the heat pump, you know, marketplaces. They came to us with some innovation or co-innovation ideas on how do we take a modern day data center, right, and look at reuse, heat reuse applications, and actually helped us co-design and co-build that, which we launched last year. So this whole area just seems like it's just ripe for us, you know, to partner even more aggressively, especially with our customers today as we think about different use cases for, in this case, you know, a heat reuse and distribution application. So I just want to mention that to the team that, you know, that there's just ample opportunities here, I think, for us to continue to innovate in this area.
Absolutely. Yep. Absolutely. So
So we
kind of
wanted,
the, I was going to say,
oh, go
sorry,
ahead, Jason.
the other part of this is really, what is this stuff, right? So when we start kind of, now we look at the next slide, you know, there's so much in this industry of like liquid cooling, and liquid cooling is such a broad word. Um, education for this audience. Often when you hear a data center or a customer talking about liquid cooling, this is usually what they're talking about. You know, the specific term for this would be called direct liquid cooling. And direct liquid cooling is where a coolant of some kind, in our case, we primarily use a 25% propylene glycol. You can imagine it's like a fancy windshield washer fluid. We make sure there's some other special stuff in there, but it's readily available. It's inert. We can recycle it, and it's relatively safe. And so we use that direct liquid cooling, to directly go into the servers, extract that heat, and go back to a larger part of the infrastructure. There are other types of liquid cooling. We won't talk about it a lot today, but there's also liquid to air cooling, which are like rear door heat exchangers or in-row coolers. Those technically, in my eyes, are liquid cooling because they use a facility water connection and then they create cool air very close to the IT. But if you don't have that facility water, it wouldn't work. So to me, that's another version of liquid cooling. And then immersion. Immersion is a type of liquid cooling where everything is submerged inside of a dielectric tank. It captures the heat. But we don't talk a lot about that because it is a very different infrastructure type. There's a lot of trade-offs, and HPE is heavily investing in direct liquid cooling because for us, this is the best way to sustain this technology, scale it out for both supercomputers and for enterprise, and it's very easy to maintain. And so this visual I always like sharing is just what are the nuts and bolts of liquid cooling. So there are cold plates, right? We take off the air-cooled heat sinks. We put on these copper cold plates. They have flexible tubes. That coolant's getting pumped through the server, and we use these dripless quick disconnects so we can quickly disengage the servers from the rack. And other than that, these operate like an air-cooled server because, again, you can see the numbers here. About 70%, this is really a marketing number. I would say it could be as low as 65, as high as 85% of the server heat goes into this liquid, and then the rest of it goes to air. And though we might ask, well, why don't we do 100% cooling on everything? And the major answer really is cost. It is expensive and timely to design a full liquid cooled solution for every server, whereas air actually is really flexible and it provides still a lot of opportunity for us to use third-party components. So this is really what goes into this infrastructure. And then in the next slide here, this is where it is at the rack level. So, the main building blocks that you can take away kind of for your vocabulary are the direct liquid cooling cold plates that are in the server. On the left there, often we'll have a rack manifold. So these might weigh, 50 to 70 pounds. They're stainless steel, and they provide the interface between the servers and the CDU that's at the bottom. So it's just a big kind of manifold, has all the quick disconnects, and all the fluid goes through them. And then at the bottom is a CDU. So this is a coolant distribution unit that interfaces between the facility water and what's in the rack, and really make sure these two fluids are separate. So the facility is managing water, secondary side's doing propylene glycol, and these mixing only happens in the plate-to-plate heat exchanger, but the fluids stay separate, and that's important for general health. So I hope that, if you have one thing to talk about the dinner table tonight, you're now an expert in liquid cooling, right? You know the pieces, you know cold
Yes.
plates, you know manifolds, you know CDUs. That'll increase your social stock for sure. So.
And Jason, given one of the questions, that we had earlier, there are a lot of apocryphal stories about, water consumption by IT, but the cooling solutions we're talking about here, right? CDUs basically recycle the fluids, whatever they happen to be. If it's water, if it's the windshield washer fluid like you were talking about. Point being is these things just run in a cycle. Pull
You
heat from
got it.
here, move heat over here, get rid of that heat, and they're taking advantage of the fact that liquids can hold heat in efficient ways.
Exactly. And that to me is one of the biggest areas of innovation we're going to continue to see. Is to exactly your point, Lynn, the secondary side is closed loop, right? We over probably a 5-year period would expect minimal evaporation because, coolant can permeate through the tubes. There's going to be some loss, but it would be in the realm of like 2 liters. On the primary side, that can be a whole mixed bag of different technologies. On the most efficient setups, which would be the best for PUE or for energy efficiency and water reuse, that also would be a closed loop. We might see water, we might see ethylene glycol, and that could go to dry coolers. The worst cases, to your point, could be these things are hooked up to the river, and river water is coming into the data center, and it could be kind of nasty. And the plate sheet exchangers could get clogged up, but then water's coming out of the river or it's evaporating. There's such a large variety, but we're seeing more and more of an investment and interest in making that primary side as energy efficient as possible, so that again we have a really great sustainability story, and this makes sense for all the users.
So we did put a poll up, and I think if I can probably swing it in here so you can see it. So it says, which of these are current challenges in your AI adoption? And some of the choices that we gave were talent, geolocation, data center, budget, and sustainability KPIs. And so it looks like talent has really jumped off the charts, but so has data center and budget. And I mean, it's kind of interesting that those go hand in hand. And so, Lynn, I think we got the question in the chat was a little bit around these measurements of magnitude, right? Sustainability metrics and magnitude. So, can you just talk a little bit on how you see those metrics come out, even in those sustainability KPIs?
Yeah, I mean the big one, by the way. So a lot of our customers ask us for things like embodied carbon footprint in our products, and all the way back to copper mining and production and transportation. Rest assured, the number one carbon footprint item in computing is the use of these systems when they're plugged into power grids that have emissions. And generally speaking, for us, that's in fact, as a company, if you look at scope 1, 2, and 3, for those you familiar with that, I don't know. Scope 1 is your direct combustion of stuff. Scope 2 is your use of electricity. Scope 3 is all the other indirect stuff. For us as a company, our biggest source of emissions by far, most of our emissions are our customers using our products. And when they plug them into power grids, and those power grids have generation sources with carbon emissions, that is the number one problem. It's the energy and emissions. And so we've put a lot of effort and services right into helping our customers measure those energy and emissions because quite honestly, when we help our customers, we're helping ourselves because this is our scope 3 downstream emissions. I don't know, Audrey, I mean, if you were targeting that with your question.
Mhm. Yeah, I mean, think a lot of people from conversations that we have,
Mhm.
they struggle with how to measure the impact of
Yeah.
sustainability. Is it an energy consumption and is it a CO2? What if there is no CO2? What if it's a clean energy source? Does it matter then?
We love you if that's the case. And I think that's a topic we'll probably touch on later on, which is, will there be a migration of data centers to clean energy sources? And actually, there we see evidence of that occurring. So
Mhm.
Yeah.
Yeah.
And
Well,
maybe, oh, sorry. Yeah, I
go,
just
go
wanted to
ahead.
add
No, go ahead,
something
Hurry.
to
Yeah.
Lynn's point, actually, you were on point, Lynn, because it's actually 66% of our global carbon footprint as a company, the whole of HPE, comes
mhm.
from our customers using our products. And to just link those 2 points together, what you mentioned, Audrey, as well, is measuring is extremely important. And this is directly linked to the question that was asked in the chat. So I have not seen that specific number, but I have seen some earlier version that say half a liter of water or
Mhm.
one bottle of water and so on and so on. And it's very important to know at least that article that was published back then, it was really an estimate of how much ChatGPT uses with each query. And that estimate was based on if I know where ChatGPT hosts let's say their AI model, which I am using, I can check how much water that data center has. There was an uptick, let's say, in the amount of water that data center is using, how much of it was allocated to ChatGPT, and this is where they get these numbers of one bottle or half a liter or three bottles of water. So it is an approximate over an approximate over an approximate, basically. And this is
And
why
these, yeah,
measuring accurately, yeah, sorry. So
yeah.
this is why measuring accurately is really important. And I'll leave the floor to you then.
Well, no, and Kareem, I was just going to build on your point because allocation, the way to think about energy consumption and who's responsible for what is unfortunately a lot of the infrastructure problem is it runs or it doesn't run. If it's running at this point to say who's using what is a matter of allocation, not a matter of measurement. It's
Yeah.
very much like how factory manufacturing overhead works. You hire a janitor, you got 5 production lines. How do you allocate the cost of the janitor across the 5 production lines? Do you do it by how much time they spend mopping the floor at each one? Do you just take 1/5 of their salary and allocate it? This is the same thing with energy and emissions. Unfortunately,
Mhm.
systems don't use energy in such a variable way that this workload is causing this precise energy consumption. The system will consume energy, whether anything's running or not. And to some extent there's uptick, but getting to the practical issues, right? I tell our customers from the consulting business, right, that you probably don't have the data center you need going forward. What you see in this picture is a distribution of data center per rack power consumption averages. And as you can see, the 40% number, that means that 40% of all the racks deployed in IT for this survey were consuming somewhere between 4 and 6 kilowatts. Now, I can tell you, even non-GPU laden systems in data centers are going to force these numbers. This whole distribution is moving to the right. This is a historical distribution. And unfortunately, it leads people operating data centers to believe that they're not far off, right? But in truth, the typical new system deployment we're involved in has racks with at least 30 to 40 kilowatts. Um, for anyone who's employing any number of, any reasonable density of systems in those racks, which as you can see is over here in that 1% range. It just tells you a lot of IT is old stuff that
Yeah.
is much less power dense.
Well, and
But
this
going
is
Well,
forward,
20,
Lynn,
this is
Lynn, are you seeing?
2024 too, right? So this is
Oh, it is.
what's radical is if we had the most real-time data
Hmm.
Many of this is going to be the averages. So 4 to 6 kilowatts, right? I laugh at this coming from the
Yeah.
world of HPC, where a
Yes.
single XD685 8-way GPU box is going to consume 10 kilowatts. And
Yes. It's
so
more than a rack
what,
in this world. Yeah.
and that's kind of the interesting thing here is this is a view of like every server in the world,
Yeah.
Of
Yes.
course, the 40% here is like Home Depot, Walmart. There's a lot of probably like point of sale system back-end infrastructure
Hmm.
that's running off of servers.
Hmm.
But what we're starting to see is this kind of like, even to play the game at all, you're
Hmm.
going to need more power and cooling because you can't buy a 100-watt CPU anymore, right? The minimum
Right.
threshold for even CPUs is like 200 to 200 watts, 250 watts. And a GPU, even in a PCIe form factor, 700 watts. And so the
Right.
whole curve is starting to move, even if you're not in HPC, right? We're just moving up and up. Power density, chip density, a lot of it is increasing.
So are we seeing guys, so this is a great discussion. Are we seeing leading indicators with customers based on Lynn's comment about, it's allocation based, where they're setting thresholds, maybe even at a workload level, and trying to enforce the equivalent of these, energy showbacks into the business
Yeah,
unit to start
we are.
forcing some redesign. Lynn,
We
can you speak to
definitely
that a little?
are.
Yeah.
You bet. So in the batch processing world, the beauty of high performance compute is that I allocate entire systems that are self-contained power consumers to
Mm.
workloads. Like I might have a batch job that's taking 100 compute nodes. And so I can take the power of those 100 compute nodes while that batch job is running and allocate all of it to that job and say this is what that job needs to be executed. And so we are seeing some of that show back coming back. And we've now started supporting that with our tooling for sure. And some of the large financial institutions have tried to do the allocation side as well. It's when you get in the back office stuff of, I've got 5,000 virtual machines running on 100 servers. It requires more intricate, I'll call allocation and the like. And the best way when we help our customers with a very large project, is if you want to focus on energy and figure out how few systems you can need to solve the entire data center problem. That's the best way to look at it. And that causes you to change how you allocate virtual machine cores and things like that. How do I make it so I can share the fewest
Mhm.
number of systems and still achieve the performance level?
Which a lot of times we see in, we come across situations with very low utilization levels on servers. That's just,
Yeah,
30%, I think, Lynn, is the 20 to 30% is pretty
true.
average. In some ways,
But
maybe
if
we're
you're in
seeing shifts
IT,
away from that.
the other hard part, if you're in IT, it's very hard though, if you know that there's some time of the month when you need 100% to take resources away. But what you can do is figure out how many cores you've allocated to all the workloads that are sharing a particular pool of systems and figure out whether you need all that allocation or not. How much memory is out there? What can you pull back on? And then how can you modernize? Honestly, more modern systems, they drive this distribution to the right, but they also consume a lot less energy per app than
Mhm.
old systems do. And so this
That's
this kind of
the practical yet optimistic.
yeah, yeah, exactly. Well, this picture tells you probably don't have the data center you need going forward because the 40% number will be, 5 stages to the right here in the next 5 years. And I think our next picture goes into your
And
choice points.
yeah, so this
No,
is
I
so
think
well,
Kareem
we've
is going
talked
to
at the
talk.
the
Yeah,
hardware level. So
yeah.
Kareem, take us into a little bit what's happening at the model level.
Yeah. Yeah. So as Jason mentioned in the beginning, that in HPC performance is king, right? And whenever we look at these early adopters, which are basically these companies that are driving more or less the change in the AI world now, the ones that are really trying to deploy AI in whichever way possible to achieve more efficient operations, for example, we're seeing that a lot of the AI model manufacturers, so to speak, are trying to build bigger and bigger models. Why? Because basically, when we're talking about a bigger model, it can give me a higher level of accuracy. That's usually the case. Now, almost a year ago, actually, it's been a couple of months ago, we saw a new player enter the game. And as you can see in the graph on the slide, you have models like the Gemini 1.0 Ultra that takes a huge amount of teraflops, right, to run. Now, with a couple of months ago, there was a company that released a certain model which was running on a very small percentage of the amount of parameters than the other models and utilized really much, much less equipment to train, first of all, as well as to run. And that model is DeepSeek. And as you can see here, and it was really at that point because DeepSeek did not do anything that was really out of the ordinary, right? They really didn't reinvent the wheel. They just used certain degrees or certain parameters of efficiency in order to do more with less, like Lynn mentioned previously. So a lot of questions that our customers or companies that are looking into adopting AI, they need to ask themselves is, A, how accurate is accurate enough? Do I really need the 100% accuracy if 95% accuracy, I can get to 95% accuracy with, I don't know, 30% less equipment? That's the question that we need to ask ourselves. Another question that we need to ask ourselves is, do I really need to train or tune actually a model from scratch? Whereas there's a lot of models that are already available on the market that I can just go off an off-the-shelf model, basically. And then how much time do I actually have to spend tuning that model? And what is the degree of accuracy that I need to achieve? And basically, this is where, again, back to Lynn's point, it's really all about the balance. How can I make sure that I have the right model, the right size model that is running on the right equipment? Because sometimes I can use equipment for, Lynn gave the example of batch of sending batches to the equipment. And there's, for example, one way to do something similar in AI is pipeline parallelism, right? In order to make sure that I'm sending orders to each and every single node that I have and be able to increase that utilization level. Because that equipment that Jason mentioned, that we're seeing nodes that are a couple of kilowatts, right? They utilize a couple of kilowatts. When they're on, they're on. Yes, they're not going to use 100% maximum energy, but they are using energy, whether I'm actually using that equipment or not. So again, back to Lynn's point. So the fewer systems you need to run your AI inferencing or tuning, because let's be realistic, very few companies in the world can actually afford to train their model from scratch. So we're mainly talking about tuning as well as inferencing. The fewer systems you need for that, the more efficient your IT operations or your IT estate is, and the more balanced it is. Yes, sorry, Anthony, go. You wanted to say something?
Oh,
No, I'm good. I'm
oh,
good. I'm
well,
enjoying.
yeah. So one thing that's interesting here is a lot of times we think about training, right, as the
Mhm.
most resource intensive moment in time of in this AI life cycle. But the largest magnitude or use will come from inference over time. So
Mhm.
these are, it's like everybody driving in their own car, right? Like in the emissions on that versus, large planes or trains and ships and stuff, right? So
Yeah.
you can think too, like this plays out in that, everyone has this responsibility in the technologies that they're choosing for different moments in the AI life cycle, they can really make an impact. And so even though you can say, I'm not training LLMs, like this doesn't
Right.
apply, if you put a model out there for inference and, it's 1,000, 10,000, and 100,000 queries a day, and you're doing this globally, it starts to add up.
Yeah, exactly. And that's basically Jevons paradox, right? The more I design systems that are more and more efficient or solutions that are more and more efficient, the more consumers I will have, which will drive
Yeah.
up the utilization. So we're looking at most probably a couple of years down the line, everybody using multiple systems of AI, just like we have smart appliances in our house, right? It started
Hmm.
with one, then the more they were getting incorporated, the more we were using them basically. So totally agree. It is expected actually to have inferencing overtake the training energy cost or resources cost in the future.
And correct me
Hmm.
if I'm wrong, but
So,
DeepSeek is kind of an example of both, right? It used inference to train,
Yeah,
mhm.
which was part of the trick.
yeah, yeah, correct.
So there's
So
different
here's,
yeah, paths. So Lynn, take us through some of these paths
yeah.
and
So
what you're seeing in the data centers.
we talked about, you probably don't have the data center you need. Right? And any modern data center you're building today, if you're not targeting at least 100 kilowatts per rack of capacity potential, whether you build it in up front or not, it needs to be available. That's if you're looking at a new data center, that's probably a minimum, and that depends on heavily on the workloads. That's really skewed towards more of a back office IT type data center. So the choice points, a lot of our customers face are: do you retrofit something you've got? Do you build a new data center? Do you just get out of the data center business with co-location? So those three on the right, and then the use of cloud, obviously for training, those are all like I'll call them the primary choice points that we see people look at first. And then where many of them end up, if they have a data sovereignty issue and they have to own their own infrastructure, or they have to host their own infrastructure behind their own firewall frequently, and this is growing very fast, end up on the left hand side here, which is with the modular data center. And I think we can look at some of the benefits of modular data centers. This is becoming the red hot approach, no pun intended, to addressing the rack density problem and, quite honestly, the lifecycle problem. You know, if you look at NVIDIA's design center discussions they've had at GTC or other shows, right? They've talked about rack densities. There's no end to the increase in the amount of power that you need to put into a very small space. So we obviously know things like liquid cooling are here to stay. But I think what you're finding is that even the data center itself is becoming aligned and reflective of the design center around the infrastructure. It's no longer the case. A data center is this sort of like all-encompassing building where whatever the technology is, you put it in there. What's happening now is that the closest environs to the infrastructure is matched to that infrastructure. And this is where we're seeing this huge growth in the so-called modular or pod data center business. And there's several reasons why pods are growing. For the past 5 years, our pod business, which is rendered from our services business, because there's a lot of, I'll call it customization, site-specific work that happens to always be associated with a modular data center. But there are some critical, huge, huge advantages that the modular data centers have over a fixed building, an office building especially. So the speed of deployment, we've had customers get these up and running in 6 months. And we're talking from the choice of a parking lot or an empty field to a data center deployed and running. The cost of doing that in terms of comparing a pod, one of these pod modular data centers, to a brick and mortar grounds up building, huge difference. We're talking 30 to 70% lower cost. The flexibility of where to site it, which is really important. In a minute, we're going to talk about an example of a customer who has 12 megawatts they need to supply to a data center with a row of racks that have 400 kilowatts per rack. So they've got two concerns there. One of their concerns was, I need to be proximate to, and this is Bristol University, I need to be close enough to the substation to get 12 megawatts. That's not, a mean feat. And then secondly, they want to use the heat. So going back to this heat reuse that Jason was talking about, and we had questions in the chat, they want to use this heat to actually heat the nearby classrooms and buildings on the campus. So they had to choose a location that was proximate to the power source and to the heat consumer. Because, by the way, the type of heat that you can reuse from a data center can't travel far. I can't have a data center on one side of town and the heat user on the other side of town. They need to be probably within a half mile of each other or less, usually much less. because this is what they call district heating. Even the fluid running that far can lose a lot of the heat. Point being, the pods, they chose a parking lot. They chose a parking lot for the data center. It was located both to the heat consumer and the power source. And we deployed a 400 kilowatt per rack solution that's going to be a total of about 12 megawatts for this data center eventually. And the pod made this entirely possible. And it's worth noting, right? These pods can be reused and recycled. We have actually recycled these data centers when the generation of equipment that they were hosting was no longer needed by the customer. They don't have to. They don't have to keep these pods in use forever. We can take them, recycle them, use them for a different customer. The embodied carbon footprint of a pod is far less than that of a brick and mortar concrete based building. And the efficiency, the ability to cool that infrastructure, to host the CDUs, Jason was talking about, host the liquid cooling, is far more purpose built than your traditional data center. So they have a PUE for those of you. I saw a questionnaire related to PUE. The PUE for these pods is usually between 1.1 and 1.2. 1.0 is perfect, right? And if you're allowed to cheat and count the heat that got reused, you can go below one. But truth of the matter is you can't get more efficient than these data centers. And people have asked us about, oh, are they secure? Well, guess what? Security is made a lot easier in some regards by virtue of the fact that no one needs to go into these pods. If I have an office building where I've taken the fifth floor and turned that into a data center, I got to have people card in, just like we do us HPE folks, like at our San Jose office, where I've got now all these users who have no interest in the data center who are sharing the space, a physical space. With a pod, there might be three people authorized to go inside, a given data center building. And trust me, when you hear all the fans running, no human being wants to be inside these pods anyway.
And this
So
this
this is
So
slide for me,
Lynn,
this slide really like captures
mm,
the use case, right? And this to me matters is, we talk about, chip densities going up, everything's harder to cool, kind of be scared, the world is changing. But there are so many ways to enter AI and liquid cooling and all the sustainability. For many users, they're going to buy one chassis, two chassis. They're going to ramp up their knowledge of AI, or they're going to go to a colo because they're kind of playing in small time. But if customers are talking, the language I hear is, our CEO said we need a world-class AI strategy infrastructure, and we have investor money to do it right now. What they're probably not going to do is try to cut red tape, build a data center, move it into their existing infrastructure. If speed and kind of cutting edge are part of the same sentence, pods play an amazing role here because we can control kind of cradle to grave design of the pods, what goes in the pods, that PUE element that Lynn talked about, right? We control that narrative. When something goes into an existing data center, there's way more parties involved. And so that's the angle I was like putting on this is, if customers are talking about speed, time to market, high performance, pods make great sense. If we don't really know what we're doing and we want to dip our feet, pods might not be the right case. But there's so many ways to slice and dice this, which is really exciting to talk
and
about.
well,
and
that's
Jason,
what we
we've
heard.
had
You know,
people.
and back to Discover, guys. That's what we heard coming out of
Yeah.
Discover, right? Which is we're moving into an operational state, and to get to that state, I need to be more agile, and and ultimately, time to market becomes a key attribute for that investment. So Lynn, what you're describing here, as Honey, we're shrinking the data center, right? And then we're bringing the
Mhm,
data center to the power. That's a
mhm.
compelling event. Like I want to underscore what I think I'm hearing you saying is that this is a seismic shift in how we're thinking about what a data center equals moving forward. And how to best drive the economics, the underlying economics of that data center, especially when time to market and agility is core here.
Yeah.
Um, is this happening today? Are you seeing
Yes.
these
So we
pods?
have you've perfect. Yeah, we have at least two partners who are subsidiaries of energy companies.
Yeah.
One of them has figured out how to co-locate data centers next to swimming pools, office parks, places where people are going to use the heat. They've actually lined up the heat consumer And what they found is here's a field, here's a parking lot. So what do you think is getting deployed for the data centers for this colo business? It's pods. And then we have another partner who has energy they call behind the meter. So think of the huge wind farms in West Texas, for example. Company's name is Soluna, and they actually have got access to what they call curtailed energy. Very quickly, in a solar farm or in a wind farm, these wind turbines can generate electricity when the grid consumer does not need it. They call that curtailed energy. It's basically generating no revenue for the energy company today. They could buy energy storage, or they could lease out their land to data center operators and let the data centers consume that excess energy. And that's exactly what Soluna is doing. So we see this move, bring the data center to where the energy is clean, and pods are a simple accoutrement to make that possible. And just very quickly, we have customers putting pods inside of buildings. Like, I don't know how to retrofit this building to host this new infrastructure, but I can bring a pod inside my building. How about that? So that's happening too.
Yeah, well, with
So just
Kareem's point, these highly distributed systems are going to have to support these inferencing, driven use cases, right? So
Yes.
so the more distributed it is, the more you need to bring data centers to the energy. This seems like a network effect is happening. That's why I
Yes.
wanted to underscore it. This is a compelling event. It's not an evolution. It's really kind of a seismic shift. And I want to hear more
Totally.
about this in the coming quarters as well as we take this discussion deeper, right, Audrey? Cool.
mhm, mhm. Yeah, so just to wrap up, there's a little bit of this conversation around the life cycle, and I know Kareem, there's different moments in this life cycle. I think that people might be playing at. It could be everything from exploring your problem statement and your use cases to really trying to fine tune and pick the right models, and or maybe it's looking at how to scale your inference and do that in a sustainable way.
Yeah, yeah. And this is kind of related to a question that was asked earlier. There was a question about what is the right measurement, right? Because we were talking about how to
Mhm.
measure the impact of your equipment. And it was, okay, is PUE the right measurement? And PUE has been used for quite a while, as in power usage effectiveness. But the thing is, and I'll get to that side, is that if I'm only looking at PUE, there's so much more that I'm missing, right? I could have a PUE of 1.0 if that's even possible, right? But to be more realistic, I can have a PUE of 1.2. At the same time, my utilization levels in my compute are at 30%. So does that mean that I'm actually running the gear as efficiently as I can? Not really. And this is why when we're talking about sustainability in AI or AI efficiency, because these two terms can be interchanged to a certain extent, right? Is where we try to have a conversation with our customers in a way that we need to deploy solution thinking. We need to think about the holistic level of the solution. So starting with, hey, do I actually need AI, for example, for this problem that I have? So what are the outcomes that I need? And of course, curating the data. So collecting what data do I need? Is it good quality data? And there was a really nice example that I once heard. So I can choose to train or tune, sorry, my model on every single YouTube video that exists, or including this one, or I can choose to tune my model using every single Wikipedia article that exists. While the YouTube data is much more vast, arguably the Wikipedia data is much more clean, right? So it's all about choosing the right data in order to train my model. And then if I do need to train, it's about choosing the right equipment to train that model. And then we go through what most of our customers do, which is tuning. And again, same thing. It's about utilizing the right tuning techniques, whether I want RAG, whether I want to fine tune, and really look at what are the pros and cons for my own special case because it really depends case by case. This is an engineer's favorite answer. Whenever you ask us anything, we say it depends, right? So it really depends case by case. Yeah. And then when I'm inferencing, do I have certain equipment that I can actually use? for inferencing? Or do I want to, as Lynn said, do I want to tune an inference in a colo? Do I want to deploy a modular data center? So it's really all about thinking about the holistic life cycle of AI.
Mhm. Yeah, I think you summarized it really well, Kareem. I think we could probably go on for another hour or two easily. I think I talked to all of you for even longer than that sometimes. So I just want to say at the end of our show here, thank you to all of our guest speakers. Um, we we hope we can bring you more kind of fantastic insights like this from HPE going forward, and we appreciate you listening and tuning in. If you do want to send us a future topic suggestion, there is that QR code that you can scan. Even if you have questions or comments, if you want to get in touch with some of our speakers, scan that QR code. I pay attention to the feedback in there. And thank you, Jason, Kareem, Lynn. Thank you all for your time and for your expertise and perspective. It's always so valuable. I learned so much from talking to all of you.
Thank you, everybody.
Thank you so
Yep.
much.
Thank you for
Yep.
having us.
And for our listeners out there, if you want to learn more about this AI transformation, if you want to, learn about even more about, the pods and some other solutions for your use cases, we have a transformation workshop that you can find through our services center that can really help you with your project. If you didn't know, we do have some educational services and learning paths that include AI content and training, as well as NVIDIA training. So if you have educational services credits, hpe.com/www/learnai will help you check out that portfolio. And I'll hand it over to Dennis to talk about the developer community.
Hello. Thank you very much, Audrey, and all the panelists for this great session. I just pull a hand of session pool just to get a quick feedback from the audience. And as you may know, I am the program manager of the HP Developer Community Program. And as part of the community program and resources, we offer a set of webinars, the AI Jam series, for example, for today, for panelist discussion on AI. But we have also Munch and Learn, which is a thought leadership type of talk, and Meetups, which is a technology talk for an HPE solution or HPE product and solutions, but also from our ISV partners and partners. And we have also a set of workshops on demand. Workshops on demand are hands-on labs that are based on Jupyter notebooks. They are available at any time for anyone who want to learn things about development, product and solutions from HP and also from our partners. We have all the links. You can scan the QR code, or I put all the links for you to join the HP developer community if you have not already joined the community in the chat. So if you look at the chat, you will have all the links to join the community, and also all the links to look at on regular basis of the calendar for upcoming webinars, probably starting from September. So thank you very much for everyone to join this discussion and this panel discussion, and have a great rest of the day for everyone. Thank you very much.